Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is linked list cycle. Okay, so you have given the head of the linked list. You have to determine if the linked list has cycle in it. Okay, so what you have given a linked list, and if there is a cycle, that means the same node is visited from another edge. That means we have a cycle in the graph. Okay, so let's see how we can identify whether the linked list contains a cycle or not. If it contains, then we need to return true. If not, we need to return false. Okay, so let's see with an example. Okay, so let's take this examples. Like this will be our head. Okay, so if you can see 3, then this 2, then this 0, then this -4, then like all these are visited. Now you come again with this next, and this again point to 2. So this node is already visited. That's why you have returning true here. Okay. So let's see how we can approach this question is basically what we can use some sort of a hash map or a set. So let's say we are using a set. Okay. So what we will do every time we encounter one node, we will insert it. So we will insert this 3. Okay. Now we will go to its next. So head will point to here. Okay. Now we will insert 2 also. Okay. After this, we will increase our head. Head will point to here. It come to 0. So we'll check whether set contains this or not. If it contains, then we return true. That means the same node visited again. If it is not, we'll insert it. So we'll insert it. Now after this, we will move our head. Head will come here. So we will check whether set contain. No, it is not containing. So we will insert it. Okay. Now we'll go to its next. Okay. So you can see the next is 2. Now we'll check whether set contains the 2. So as you can see, this set is containing this 2. So we just return true. Okay. So if you calculate the time complexity for this is basically order of n for the time for the length of the linked list, and similarly you will take a space complexity also, so that will also order of n because you will insert every node in the set. Okay, so in the question it's also asking, can you, like, if you try with this approach it will submit it, but it is asking can you do the same problem with order of one space complexity. Okay, so let's see how we can approach that. Okay, so let's take the same example again. We will use a algorithm which is fluid cycle detection algorithm. So what it's saying is you can take two pointer, like you will take two pointer. One is slow, okay, which will start from head, and you will take one fast pointer, okay. So what you will do, every time your slow will move only one time, like slow will to move like slow dot next, and your fast will be fast dot next dot next. Okay, so if there is not cycle in the graph in the linked list, what it will do, it will go to the null condition. Okay, and you will, like, whenever your fast reaches to null, you will just come out of the loop and you say like there is no cycle. But if there is by chance, let's say there is a cycle, then slow and fast will meet at a point. Okay, so let's debug this. So what we will do, we will check whether slow is equal to fast. So as you can see, right now slow is not equal to fast. So what we will do, we will increment our slow will point at here, this will be slow, and fast will point to 2 steps. Okay, so fast will come here. Now again we will compare whether 2 is equal to 4. So this is not equal to, so we'll move our slow by 1, and we will move our fast by 2. So 4 next is 2, and after this come to here, so this is come to here. Okay, now you will compare whether this slow node is equal to fast node. So that means you traverse the same node again by different next node. So that in that case we just return true. Okay, let's take one more example. So let's do it like this: 1, 2, 4, 6, 7. Uh, this will this is pointing to this two. Okay, So we'll start our slow. So slow will be here and fast will be here. Okay. So we will compare whether slow is equal to fast. So this is not equal to. So we'll move our slow. So we'll come here and fast will move twice. So fast will come here. Okay. After this, we will check slow move to one step and fast will move to two step, one and two. So this will be come at here. Fast is come here. Okay. We'll compare whether slow is equal to fast. So this is not equal to. So after this, we'll increment our slow pointer. So slow will point at here and fast will come at here. So as you can see, both are pointing to the same node. So that means we have a cycle in the graph. If there is no cycle, then fast will reach to the end of the null. Okay. So the time complexity for this is basically, you can say you will do for all the nodes. But let's say if there is no cycle, you will reach to the at half a length. So it will be equivalent to order of n. And space, it's order of n space complexity. Okay. So let's write the code for this. Okay. So we need two pointer, and let's handle base case also. If your head is equal to null, or we can say your head dot next equal to null, then you just return false, because in a single node there is no cycle. Okay. Now what you will do after this, we'll take two pointers. So list node first equal to head, and second, or let's give the same name, slow, and a fast, which will point to head dot next. So if your while, what we will do, while fast is not equal to null, and fast dot next is not equal to null. Why are we checking this condition also? Because fast is moving twice, so we need to confirm whether the next element is also not null, then we can take the next element also. Okay. So we will check if slow is equal to fast. That means we found a node that is already visited, return true. Else we do slow equal to slow dot next, and fast equal to fast dot next dot next. Because of this line, we have to add this end condition. So let's say fast dot next equal to null. Okay. And you will do null dot next. So this will be error, like it will give you error. Okay. So after coming out of the loop, if there is no node that is having the same slow and fast, so we'll just return false. Let's run the code. So as you can see, our code is accepted. Let's submit it. So our code is also submitted. Hope you like it. Thank you for watching my video.